Here in this video, we are solving two questions that appeared in NEET 2023 in the moving charges and magnetism chapter. Let us see the first question. A very long conducting wire is bent in the form of a semicircle from A to B as shown. The magnetic field at a point is given by. See, we have to see this question a little carefully. See this. This is a current carrying conductor from infinite length. On this point, due to this current carrying conductor, there will be a magnetic field. How much is that? Let us try to write that first. From an infinite wire carrying a current at a point P, magnetic field B equal to mu naught by 4 pi I by R. Here is the point P at a distance. Around the line there is no magnetic field, right? I by R. This is the magnetic field. What is the direction of that is, we have to use the right hand thumb rule. How we have to use the right hand thumb rule is, simply use the thumb to hold your fingers. Along the direction of this current carrying conductor. Now, you have to curl your fingers like right, yeah. So the direction of curled fingers gives a direction of the magnetic field. So look here in this case, your thumb will be, I'll take a different color so that it will be visible for you. Your thumb will be like this, and your curled fingers will be from the top to the bottom. You have to curl it like this, right? You are curling fingers onto the point, towards this point into the paper. You have to curl your finger. So I just want you to hold this wire with your finger and see how your fingers are curled. At the point P, they are coming into the paper. So this is coming, magnetic field is cross, that means into the paper. Let's have a look at this also. There is another one, right? Here also you have to put your finger this way. This is how you put your finger, right? And now put your finger, use your hand and curl your fingers. If you can see your fingers going into the screen at the point P. At the point P, they are going in. So due to this part as well as this part, magnetic field due to the first one as well as the second one is the same. Mu naught by 4 pi I by R, both are into the paper. And there is another part. This is a semicircle. So due to that circle, due to that part, due to some semicircle or part of a circle, magnetic field is mu naught by 4 pi I by R into theta. Being a semicircle, that angle is pi itself. I by R, theta is pi. Pi and pi will cancel, that is mu naught by 4 I by R. Look at the direction. Now you have to, say this, the wire is in a curled part. Whenever the wire is curled part, you shall apply the right hand thumb rule in a little different way. Now you curl your fingers along the wire this way. This is how you have to curl your fingers, right? Curl your fingers this way. And just use your fingers, and you can see your thumb going into the sky, outwards. So that means going into the sky, outward. So due to this third part, it is outward. The magnetic field at the point P is sum of all these things. You have to add all of them. So B at the point P is B1 bar plus B2 bar plus B3 bar. I mean to say the vectors. If you see carefully, when compared with this, mu naught by 4 pi I by R, for both of them you have to add it 2. Mu naught by 4 I by R. In the denominator there is no pi, so this B3 is obviously greater than B2. So resultant is B3 minus 2 times of B1 or 2 times of B2 because B3 is dominating. So what is that B3? Mu naught by 4 I by R minus mu naught by 4 pi I by R of 2 because there are 2. Now I can take mu naught by 4 I by R as common. 1 minus 2 by pi is there. This pi is there. 1 minus 2 by pi. As outward is dominating, your answer is also outward. So your answer is pointed away or outward. This one is the answer for the problem. So to solve these problems, you need to know the basic concepts, formulas, know them so that you will be able to answer. Let's have a look at the other question. This is the other question. A wire carrying current I along the axis, x-axis is having some length L, current magnetic field is given for you. What is the magnitude of the force acting on that? We can write a force formula in a current carrying conductor in a magnetic field is BIL sin theta. If you write it in vector format, actually I of that is L bar cross B bar. So I means current. So the current is I here. L bar means L along x-axis, that is I cap. Cross B bar means whatever is given for you. 2I plus 3J minus 4K. Now I of, I cross I is 0. How do you find cross product? I cross I means I sin theta. Magnitude of I is 1, that's a unit vector. Sin, the angle between the similar vectors is 0. Sin 0 is 0. So that is equal to 0. I cross J, to find out the direction, you have to draw a circle I, J, K. So I cross J is K if it comes in the same direction. So next what it comes is I cross J. So L 3 I cross J, L into 3 into I cross J is plus K. Next I cross K. I and K are in the opposite direction, therefore it becomes minus J. So plus, it is minus L into 4 into I cross J is, I cross K is minus J. So this is I of 3LK minus of minus is plus 4LJ. But K and J are perpendicular to each other. The resultant will be root of 3L square plus 4L square, that is 5I. So your answer will be 5Li. That's the answer for your problem. That's how we solve this question. Thank you for watching.